Good morning, students. A hearty welcome to all. Hope you are fine and healthy. Today, let's have something interesting to add knowledge in chemistry subject. So let's start with the chapter 1 of class 10th, that is periodic table, periodic properties and variations of properties. As you have studied in class 9, that elements need to be classified into certain groups and periods in order to study them in an organized way. You have also learnt that many physicists and chemists in the past made attempts to arrange elements in various ways, and thus their efforts have made it easier for us to understand the grouping of elements. The first scientist who contributed in arranging the elements was Daubeney. He made a group of 3 elements. Those 3 elements, they were having the same properties. This is known as a triad. Daubeney gave law of triads, which states that atomic weight or atomic mass of the middle element was the average of the atomic weights of the other 2 elements. Example, a group of 3 elements like calcium, strontium and barium. Atomic weight of strontium will be equal to the average of calcium and barium, that is the 40 plus 137 divided by 2, that will be 88.5, which is approximately equal to the atomic weight of strontium. There was a drawback, that was all the known elements that time could not be arranged in the form of triads. There was another scientist named Newland who gave Newland's law of octaves. It states that when elements are arranged in order of their atomic masses, every 8th element, beginning from any element, resembles the first element in its physical and the chemical properties. It's the same way as the 8th note on a musical instrument resembles the first one. But this method was also discarded. There were 2 demerits. First, it was not working for heavy elements, that is beyond calcium. Second, more elements which were getting discovered could not fit in the Newland's law of octaves. There was another contributor whose name was Dmitri Mendeleev. He gave the first periodic table of elements. Based on his law, the properties of the elements are the periodic function of their atomic masses. He placed 63 elements which were known at that time in vertical columns, that were groups, and horizontal rows, that were the periods. He also predicted the existence of those elements which were yet to be discovered. There was a drawback. He could not explain the positions of certain elements such as rare earth metals and isotopes. Then came Henry Moseley, who put forward the modern periodic table. It was based on atomic numbers. Moseley suggested that the atomic number and not the atomic weights should be the basis of classification of the elements. So, the modern periodic table states that if the elements are arranged in the increasing order of the atomic numbers, the properties of the elements are repeated after definite regular intervals or periods. Later on, Niels Bohr gave the extended form of the modern periodic table, and it is known as long form of the modern periodic table. This is a periodic table, a tabular arrangement of elements in vertical columns, known as groups, and horizontal rows, known as periods, showing the regular trends in physical and chemical properties of elements. There are total 18 groups. This numbering of the groups was recommended by IUPAC in 1984 and known as long form of periodic table. Earlier, these 18 groups were divided into 2 subgroups, subgroup A and subgroup B. Subgroup A from 1A, 2A, 3A, 4A, 5A, 6A, 7A They are known as the representative elements or the main elements. Subgroup B, 1b, 2b, 3b, 4b, 5b, 6b, 7b. They are known as the transition elements. So there are 7A groups and 7B groups, 1 0 group and 3 vertical columns, making group 8 collectively. So total comes to 18 groups. Group 1A is for the alkali metals except the hydrogen. They are highly reactive and they react with water, forming the strong alkalis. Alkalis are the bases which are soluble in water. Group 2A, they are forming by the alkaline earth metals, forming the weaker alkalis as compared to group 1A. Group 13 or 3A, this is known as a boron family because boron is the first member of the family. Group 14, 4A, this is known as a carbon family because carbon is the first member of the family. This is known as a nitrogen family, that is the group 15, 5A, because nitrogen is the first member of this group. Group 16, this is known as the oxygen family. This is also known as the chalcogens, ore forming. Group 17, halogen family or the salt formers. They form the salt with the alkalis. Group 18, also known as a zero group. This is formed by the noble gases or the inert gases. They have their octets complete. That's why they are stable. Now, group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11, group 12. These are known as the transition elements. They are known as the transition elements. They have 2 outermost shells incomplete. They have their 2 outermost shells incomplete. Group 1, group 2, group 13, 14, 15, 16, 17, they are known as the representative elements or the main group elements because their outermost shell is incomplete. Group number is determined by the number of the electrons present in the outermost shell, or you can say the valence electrons will tell you the group number of the element. Periods. There are 7 horizontal rows. 1, 2, 3, 4, 5, 6, 7. So 7 periods are there. Number of shells present in an atom determines the period number. For example, if we take one example, lithium. Atomic number is 3. Its electronic configuration will be 2, 1. How many shells will be there? 1, 2. 2 shells will be there. So, it will come in period 2. Let's take another example. Sodium. Its atomic number is 11. Its electronic configuration will become 2, 8, 1. How many shells? 1, 2, 3. So, number of shells are 3. So, period number is also 3. Now, if we talk about the group number is determined by the number of electrons present in the outermost shell. So, over here, in the outermost shell, we have the one electron. So, its group will be 1. Here also, we can see in sodium, the valence electrons are 1. So, the group number will be 1 of sodium also. We have the third period, which is of sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. These are known as the typical elements. And why are they known as the typical elements? Because these elements, they show or they summarizes the property of their respective groups. Let's understand another feature of the periodic table, that is periodicity. What is periodicity? The properties that reappear at regular intervals, or there is gradual variation, that is increase or decrease at regular intervals, are called the periodic properties. And the phenomena is known as the periodicity of elements. What is the cause of periodicity? It is the repetition of similar electronic configuration, that is, having the same number of electrons in the outermost shell. Let's explain with the example. In group 17, that is halogens, elements are fluorine, atomic number 9, electronic configuration 27, number of shells 2, so period second. Chlorine, atomic number 17, electronic configuration 287, number of shells 3, so third period. Bromine, atomic number 35, electronic configuration is 28187, 4 shells, so fourth period. Iodine, atomic number 53, 28187, number of shells 5, fifth period. Astatine, 85 atomic number, 28132 number of shells 6, so sixth period. As we can see, in the outermost shell they have the same number of the electrons, that is 7. Hence halogens, they have the same properties, like they are colored nonmetals, they form negative ions, they are very reactive, they are found in combined states, they are slightly soluble in water, but they dissolve much better in organic solvents like carbon disulfide, chloroform, alcohol, etc. Melting in a boiling point increases down the group, and they are the good oxidizing agents. What are oxidizing agents? They are the agents which accept the electrons and they become reduced. Let's study about shells or orbits. What are shells? They are the certain defined circular paths around the nucleus where electrons are revolving. If we go down a group, the number of shells increases one by one. Let's understand with an example. If we take group 1A or group 1, alkali metals like lithium, sodium, potassium, rubidium, cesium and francium. Lithium, atomic number 3, electronic configuration 2, 1, number of shells, there are 2. So period second. Sodium, atomic number 11, electronic configuration 281, number of shells 1, 2, 3 and period third. Potassium, atomic number 19, electronic configuration 2881, how many shells? 4 shells, so fourth period. Rubidium, atomic number 37, electronic configuration 281, number of shells 5, period fifth. Cesium, atomic number 55, electronic configuration 281, number of shells 6, so sixth period. Francium, 87, electronic configuration 281, number of shells 7, so period seventh. So as we are moving down the group, the number of shells are increasing one by one. Now let's study across a period. From left to right, number of shells remains the same. As we know that the number of shells determines the period number. For example, if we're talking about the second period elements, the number of shells remains 2. For the third period elements, the number of shells remains 3 and so on. Let's understand what is valency. As you all know, it is the combining capacity of the atom of an element. It's the number of the electrons an atom can donate or accept or share to complete its octet. Valency depends upon the valence electrons, or you can say it depends on the number of the electrons present in the outermost shell. As it is the combining capacity, so valency is always a positive value. Down the group, as we go down the group, valence electrons remains the same. Hence, valency also remains the same. We know that the number of electrons in the outermost shell determines the group number. So, for a particular group number, the valence electrons will be the same. Across the period, as we are moving from left to right, valency increases only up to group 14, where it becomes 4. And then it decreases, that is group 17, it becomes 1. Let's understand this. If the number of electrons present in the outermost shell, that is the valence electrons, are 1, 2, 3 or 4, then their valency is 1, 2, 3 and 4 respectively. But if the number of electrons present in the outermost shell are 5, 6 or 7, then their valency will not be 5, 6 or 7. Their valency will be 8 minus 5, that is 3, 8 minus 6, that is 2, 8 minus 7, that is 1. For example, oxygen atom. The atomic number is 8, so its electronic configuration will be 2, 6. Valency will not be 6. The valency will be 8 minus 6, that is 2. So oxygen has 2 valency. Let's study an example. There are different groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, 0 group. Group number 1, 2, 13, 14, 15, 16, 17, 18. We have taken the elements of second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Their atomic numbers are lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9 and neon 10. Electronic configuration can be written with the help of atomic number. So atomic number 3, electronic configuration is 2, 1. Atomic number 4, electronic configuration is 2, 2. Electronic configuration here 2, 3 for boron, 2, 4 for carbon, 2, 5 for nitrogen, 2, 6 for oxygen, 2, 7 for fluorine and 2, 8 for neon. Number of shells, we can see there are 2 shells for lithium, beryllium 2 shells, boron 2 shells, carbon 2 shells, nitrogen 2 shells, oxygen 2 shells, fluorine 2 shells and neon also 2 shells. Why there are 2 shells? Because they are the elements of the second period. So period number is resembling with the number of the shells. Valency. Over here valency will equal to the valence electrons. That is 1 here, 2 valency, 3 electrons in the valence shell, 3 valency, 4 electrons in the valence shell, so 4 valency, 5 in the valence shell, but there is no 5 valency, maximum is 4 valency, so it will be 8 minus 5, that is 3 valency. Here 8 minus 6, 2 valency, 8 minus 7, 1 valency and 8 minus 8, 0 valency for neon. Let's take one question. The element S with mass number 32, atomic number 16 is given. You need to find the electronic configuration. Electronic configuration we can find with the help of the atomic number, that is 16, which will be 286. Group number, the number of the valence electrons determines the group number. Here valence electrons are 6, so 6A is the group or group 16. Period. Number of the shells, 1, 2, 3. Number of shells determine the period, so third period because 3 shells are there. Valency, it will be 2 valency because there are 6 electrons in the outermost shell and 6 can't be the valency. It will be 8 minus 6, 2 valency. Metal or a non-metal? As we know that it will try to accept the 2 electrons and completes it noble gas configuration and become 288. So it is a non-metal. Reducing agent or oxidizing agent? Oxidizing agents because it will going to accept the electrons and itself getting reduced. So it is the oxidizing agent. At the end, dear students, I hope you have understood the concepts. Meanwhile, you can solve the given questions, and for your reference, you can go through few videos whose links are shared here. Thank you.